This video is likely to be a difficult one. In this video, we're going to learn about how to write expressions for what the nth term of a sequence is. So if I give you a sequence, can you come up with what the expression is that will give me the nth term or any given term in that sequence? And it requires a lot of intuition. It requires a lot of just kind of patience and practice in recognizing patterns and seeing them. So let's get started. So the first example that I have, write an expression for the nth term of the sequence, which begins 1, 5, 9, 13. This is one and a very common style of sequence that you might have to deal with. In this case, you'll notice that there's sort of a common difference, right? Between each one of these things, we're going up by 4. And to me, what that means is every time n gets incremented, in other words, every time n goes up by 1, we have to add 4 more onto this thing. So what that sort of means is it means that your a sub n will have something to do with 4n, right? Now we just sort of have to figure out, like, okay, what happens, right? My thought here is, well, if it was just 4n, then the first term would have been 0, the next one would have been 4, the next one would have been 8, and the next one would have been 12. And when we look at our sequence, we're like, hey, all of my numbers are 1 bigger than that. So that means that my sequence should be a sub n equals 4n plus 1. It's almost like we're saying my first term is 1, and I'm adding on a difference of 4 each time, right? So it almost would have been better to start this by saying my first term is 1, and I'm adding on 4 times however many terms I'm looking at. Alright, so here's another sort of common sequence, right? This one, we have 0, 3, 8, 15, 24. And I don't know if you guys recognize this pattern. The hint that I'll give you is that this is very close. In other words, it's one off from some other pattern, right? And so what you might recognize here is, hey, these numbers here all seem to be 1 less than a perfect square, right? Like 1 squared is 1, and this is 1 less than that. 2 squared is 4, and this is 1 less than that. 3 squared is 9, and this is 1 less than that. So it's almost like I'm looking at this and saying this first number appears to be 1 squared minus 1. This next one is 2 squared minus 1. This next one is 3 squared minus 1. This next one is 4 squared minus 1. And this next one, indeed, is 5 squared minus 1. That was a really bad 5. So how can I work with that, right? Well, what we recognize is that every one of these terms had this sort of consistent minus 1 at the end of it. In other words, that part doesn't change as n changes, right? So we could sort of conclude my bn or an or whatever you want will be something minus 1. Now the question is, what's the something? And it seems pretty clear that it's something squared. But what's being squared? Is it n? You'll notice it's not n that's being squared, because this thing started at 1 squared, then 2 squared, then 3 squared, 4 squared, 5 squared. So how would I get this to be 1? Well, if I'm starting at 0, I should do n plus 1, right? The idea here is that I'm taking my n, which starts at 0, and I'm adding 1 to it to make it 1, then squaring it and subtracting 1. Like I said, these are sort of complicated problems, and some of you may be seeing them totally fine, but it takes some practice to sort of get the hang of this stuff. I expect us to talk about this a fair bit in class tomorrow. So now I have one more example, and it's a little bit of a complicated one. These are fractions, and so you may immediately be scared of the fractions, but the reality is a fraction is just a numerator and a denominator. If I can find the pattern of the numerators, put that in the numerator, find the pattern of the denominators and put that in the denominator, then we win, right? You'll notice the denominator one is actually very similar to the previous pattern that we had, right? This 3 appears to be 2 squared minus 1. This 8 appears to be 3 squared minus 1. So that's sort of what that one is. In the numerator, you've got a pattern that's going 1, then 3, then 5, then 7. Those are each changing by 2 each time. So I'd like you guys to sort of pause the video for a minute, think through how you would set up the numerator and the denominator, and try and write those out. You may have noticed that the signs are also changing. Don't worry about that. Just get the numerator and the denominator set up. Try that on here. So for the numerator, I notice that it's 2n and then I'm going to do plus 1, because if I'm starting with n being 0, then my first term should be 2 times 0 is 0. I'm adding 1 to allow it to start at 1. In the denominator, I need to start at 2 squared minus 1. So I'm going to do n plus 2 squared. So those are my numerator and denominator expressions. Now I need to make this thing alternate. And I'm going to show you right now how you make any series alternate. What you do is you multiply by negative 1 raised to some power. Right? And the question is, what is that power going to be? Well, if my first term is 0, with n being 0, and my first term is positive, I'm going to raise this to the n power. And what happens is, when n is 0, this is 1, and the term stays positive. When n is 1, or actually anything odd, this will be negative, and it will make the entire term negative. So, this does two things. One, it shows us how to deal with fractions. We just do the numerator and the denominator differently, separately. It also shows us how we make a sequence alternating. You take negative 1 and you raise it to a power. Good stuff.